Nepal Engineers Association र साउथ एसिया लाइटिङ नेटवर्क र संयुक्त रूपमा आयोजित यस टक्सो प्रोग्राममा यहाँ हलमा उपस्थित सम्पूर्ण इन्जिनियर तार्किक म्याडमहरुमा हार्दिक स्वागत गर्न चाहन्छु। साथै फेसबुक लाइभ मार्फत जोडिनु भएका सम्पूर्णमा स्वागत गर्न चाहन्छु। आज विशेष गरी हामीले लाइटिङको विषयमा हाम्रो टक सो राखेका छौं, जुन 6औं सिरिजमा छौं। कार्यक्रम सुरु गर्दै गर्दा म हजुरलाई केही चीजहरु चाहिँ सचेत गराउन चाहन्छु। हामीले लाइभ चाहिँ यहाँबाट गर्ने भएकाले तपाईहरु चाहिँ मोबाइल चाहिँ साइलेन्स राख्दिनु होला। त्यो टक प्रोग्राम भरिको टाइम फ्रेममा मोबाइल साइलेन्ट राख्दिनु होला र सकेसम्म हाम्रो स्पिकर एचकोमै भएको कारणले गर्दा तपाईहरुले बोलेको सम्पूर्ण रेकर्डेड हुने भएको र साइलेन्स बस्ने होला म अनुरोध गर्न चाहन्छु। यस कार्यक्रमलाई औपचारिक रूपमा सुरु गर्नको लागि यस कार्यक्रमको अध्यक्षताका संकल्प गरिदिनु हुन नेपाल इन्जिनियर्स एसोसिएसनको अध्यक्ष डाक्टर हरिबहादुर तोलाङजी हार्दिक गर्न चाहन्छु। त्यसैगरी अतिथिको आशीर्वाद गरिदिनु हुन प्रोफेसर डाक्टर श्रीराम शर्मा सरलाई हार्दिक अनुरोध गर्न चाहन्छु। On behalf of Nepal Engineers Association, I would like to welcome our guest, Professor Sandimas Gomez and Engineer S. Gopakumar. त्यसैगरी म ढिला नगरिकन आजको सिरिज हामीले दुईटा सिरिजमा टुक्राएका छौं। विशेष गरी आजमा सुरुमा हाम्रो डाक्टर श्रीराम सरले छोटोमा आफ्नो सर्ट प्रेजेन्टेसन राख्नुहुन्छ र त्यसपछि 30 मिनेट्स दुईजना हाम्रो प्रस्तुताले आफ्नो प्रेजेन्टेसन राख्नुहुनेछ। मलाई लाग्छ त्यो धैर्यताका साथ सुनिदिनु हुनेछ र हजुरहरुमा कुनै कन्फ्युजन भए त्यसपछि हामी क्वेशन सेसन राख्छौं र फेसबुक लाइभ मार्फत जोडिनु भएका कसैले पनि केही कमेन्ट भएमा हजुरले उहाँलाई चाहिँ च्याट मार्फत सोध्न सक्नुहुनेछ, प्लस कमेन्ट मार्फत सोध्न सक्नुहुनेछ र अन्तिममा हामीले आजको गेस्टलाई चाहिँ टोकन अफ लभ वितरण कार्यक्रम हुँदै हामी कार्यक्रम समापन गर्छौं। म अब ढिला नगरिकन आजको हाम्रो यस सेसन सुरु गर्न चाहन्छु र यो माइक चाहिँ प्रेजेन्टेसनको लागि यो माइक चाहिँ प्रोफेसर डाक्टर श्रीराम सरलाई हस्तान्तरण गर्न चाहन्छु। हस्, धन्यवाद।
Thank you so much for the introduction and warm welcome. This is Sriram Sharma from Amrit Science Campus, as well as chairing Fourth Asian Lighting Network. I will not take much time today, although I have been given this topic of fundamentals of lighting, as we have got the two experts from global experts with us today. Although this is not for the first time they have been here, it is also mention worthy that we had, along with the Engineers Association, organized a program in 2019 that was held in Hotel Himalayan, but mainly dedicated to the electrical engineers. So this is particularly I am associated with the Engineers Association for the third time, and this kind of program the second time. And this is the time when both the gentlemen from abroad arrived Nepal for different purpose, particularly in the mission is the same, but in the invitation of different organizations, Kathmandu University and Tribhuvan University, and along with South Asian Lighting Network. But we catch this opportunity to get their knowledge among and share the knowledge among the engineers, not only from the engineering discipline but also from other disciplines. As we all are aware that lightning kills more than 100 people in Nepal each year, and billions of rupees worth of property damage by lightning being incurred every year in Nepal. Though this damage and property loss and killings of human beings by lightning is mostly underrated. Most of the focus in disaster as well as government sector is on structural strength, and also on disaster aspects we are focusing on landslide, flood and earthquake, mostly on earthquake. We are mostly overlooking the deaths incurred due to lightning hazards or electromagnetic or electrical hazards. So today, my friends will be talking about how to incorporate the lightning protection measures within the structure itself without having external system. So two people are here to experts are here to discuss about all this, and I am not taking much time as we are time bound, so I am not taking much time to go for the details of lightning because all of you are aware of lightning is a huge, massive electrical discharge that flows from cloud to ground. This is all, and how we get the protection from the lightning, and particularly using the natural building components will be discussed by two of them. So I will not take much time today. Just by saying so, I would like to express my gratitude to the Nepal Engineers Association, and also would like to express my congratulations to the newly elected team. And I hope your team, newly formed team, will pay very creative, constructive, and new path to the society and the country itself. Wish you all the best. With that, I would like to invite Professor Chandima Gomez, all the way from South Africa, who is the distinguished professor of high voltage engineering and lightning protection, and of course, technical committee member of IEC, different chapters of IEC, International Electrotechnical Commission. So, Professor Chandima, it's over to you. Thank you so much.
Oh, sorry. Thank you very much for the introduction, and good afternoon, ladies and gentlemen. So in the next half an hour, I'm going to give you a very brief idea, an idea in brief about how lightning protection, something considered a costly business, be converted into a rather cost-effective, affordable business. Okay? And I'm sure that most of you have heard about lightning protection at least. Some of you are involved with lightning protection, and some of you may have experienced the bad impacts of lightning. Now, lightning is a very vast area of research and engineering. So, lightning protection is a part of lightning science. And under the lightning protection, again, we have several sectors, and one is the protection of buildings from a direct lightning strike or side flash. That's what I'm going to talk today. And my colleague, Mr. Gopakumar, is going to talk about the impact of lightning on electrical systems and how it is going to affect you and how we can mitigate the problems. Now, if I go here I'm not going to any details of lightning protection because of the time constraint. I'm sure that all of you know that lightning protection is basically these four parts: air termination, down conductor, and an earthing system. Looks very simple. And then all metallic parts exposed to the external world should be either properly connected by electrical means to the lightning protection system, or they should be separated by a certain distance. If you forget about that part, basically air termination, down conductor, and earthing. Although it looks like quite simple, the problem is that when you are designing the lightning protection system according to either IEC standards or Indian standards, they are very similar. And in Nepal, the standards are being developed. You need a large number of metal components, metal rods, metal tapes, then again metal rods or tapes, maybe copper, maybe some parts you can replace copper by aluminium, maybe GI, galvanized iron. So the problem is that the base material of lightning protection systems at present, copper, is very expensive. Just a couple of days ago, we checked in the market and found that 1 meter of copper tape, which we usually used for lightning protection systems, 75 millimeters squared, is about 1,800 rupees a meter. So because of this cost, most often the vendors who are selling fraudulent and not scientifically proven lightning protection systems get the advantage. They try to sell you products where they say that one rod, one down conductor, and one earthing rod is enough. This is a big problem in many countries. These systems have failed. And even with that, for that particular rod, we call them ESC rods, you have to spend quite a lot of money, sometimes 300, 400,000 rupees for the rod. However, if we are sticking to the IEC standards, the International Electro-Technical Community Standards, then they are giving us very nice and neat guidance on how to do the lightning protection at a much less cost. That is by using these so-called natural components. This word is really misleading, the word natural components. It does not mean some trees or some rocks or something. Natural component in this particular case mean anything that you use to develop the building, construction of the building, which is originally not supposed to be a part of the lightning protection system. For an example, roof of a building is not for lightning protection, it is for something else. A metallic water tank, metallic downpipe, the steel reinforcement structure, these are not meant for lightning protection, but we can use them for lightning protection according to the standards. So now I'm going to tell you how the three major components, air termination, which will intersect with lightning step leader, down conductors, which take the lightning current from roof level to the ground level, and earthing system, which neutralizes the earth, the charge brought by the down conductors into the soil. We'll start from the air termination. Actually, you can use the metal roof, metal tank, or whatsoever is on the roof level as your lightning protection system's air termination. However, you should adhere to this table. What does that it mean? The last column gives you the minimum thickness required to use a natural component as the lightning air termination if your building is not housing any explosives or ignitable material. So now you see that usually, although there are many material, in most South Asian countries, people use either steel or aluminium roofing material if they are using metal. And those are the two minimum thicknesses given. But in most parts of in this region, people find 0.45 as the thickness of these corrugated metal shades, slightly less than the limit. But what I say is that will be okay. And if your installation is storing, say, petrochemicals or explosives or firework material, then the thickness should be much higher. Okay? So let's go to a few examples. Now, if you take this factory, you do not need to have air terminations. You take, this is a defense system where they store ammunitions. In this particular case, if you are using the roof as the air termination, then what would be, say for an example, it is steel, then you need a higher dimension. For an example, let me run into that. If it is steel, it should be 4 millimeter thick at least. And then, if it is a naphtha tank, but if the roof is fixed roof type, there is another type called floating roof. What I am telling is not applicable to that. Only if the oil tank is made of fixed roof type, then if the thickness is satisfying the minimum dimensions given in that table, you can use that itself as the air termination. You don't need any copper rods or anything to be installed. However, I am emphasizing you that if it is the floating roof type, we have a very different lightning protection mechanism. And then imagine that if you want to have, now this is not natural component, sometimes natural component, there may be vertical parts in the building which are either natural, that means it is used for some purpose, or purposefully made for lightning protection, then their cross-sectional area should be according to this table. And then I will show you a few examples. This is a hotel from Sri Lanka, Kandalama Hotel. It is 1.2 kilometers in width, actually, one of the longest hotels in this region and one of the most beautiful. It is, when you are coming to the hotel, you don't see that there is a hotel, although it's a 1.2 kilometer long hotel. You see the jungle, because everywhere you will find vertical growth and horizontal growth. And then they asked me to do the lightning protection at a much later stage after the hotel was constructed. And then they started imposing conditions on me that no air termination should be installed because it will damage the aesthetic appearance of the building. So that I had a big problem at the beginning. And finally what I did was I designed air terminations which looks exactly like the cactus trees. There are several cactus trees there. And then painted it with green color conductive plate. Okay? And it is copper. Usually copper get green color anyway after some time. And so that this is my design, and then they accepted it. So usually the architects are very particular about the lightning protection system. They most often object to your design. So the best thing is to go in line with them without opposing their ideas. Try to satisfy what they want, because they are the kings of a building construction. Okay, so if there are buildings with metal parts like that, especially if you know that the building is having these decorations, then talk with the civil engineer and architect and see whether you can persuade them to build up at least few parts of this metal to satisfy those conditions I showed in the table, the thicknesses and so on. It will be much, much less costly compared to having external lightning protection. Few pictures. And also, especially in this part of the world, you will find that people use various religious symbols on top of the buildings. And if you get to know that the building is going to have such thing, then again talk with the building owner, architect and civil engineer, and you can convince them that the number of items you need for the lightning protection to be constructed according to the standards that you follow, and use them as the air termination system. So let the credit goes to the God. But if you are protected, then it is okay. And okay, that's about the air termination. And then when it comes to the down conductor, the best thing you can do to avoid external down conductors is to use the steel reinforcement of the building. But one thing that you should not forget is that according to IS standards, when you are using the steel reinforcement of the building as the down conductor system, there are 3 conditions to be satisfied. One is all bonds of the steel reinforcement should be, not all, but they say 50% at least, securely bonded by bonding wires, of which the total length should exceed 5 centimeters, or you can weld them if the civil engineering standards allow you to do that. Then the overlapping distance between vertical bars should be at least 20 times the diameter of the rebars. And the third one is, from top to bottom, the total resistance of the steel reinforcement system should be less than 0.2 ohms. Now you will understand that the third one you can measure actually even when the building is constructed. But the first 2 you cannot ensure after the building is constructed. And then, so once you do that, what you can do is you can take the extension of the rebar system, the electrical extension taken out from the building, and then connect it to an air termination system. Okay, so here what you see is that actually this is that I am involved, where they have taken the electrical extension out and then connected it to the air termination. But here there is another problem. Many civil engineers do not allow taking the metallic continuation out of the building. So then, unfortunately, we do not have a compatibility between civil engineering standards and lightning protection standards. So what we do is, we usually recommend taking this connection out from the top of the building to be connected to the air termination, and from the bottom of the building to be connected to the earthing system through stainless steel. Because stainless steel, especially 306, is not interacting either with steel reinforcement bars or the material you are using for air termination system, either copper or aluminium usually. And then sometimes people are little worried that the lightning protection engineer can tell the civil engineer that, okay, the first two conditions that I showed you, 20 times the diameter overlapping and then 50% of the bonds securely bonded. This to be done during the construction stage, but nobody can ensure it because most often lightning protection designer and civil engineer are two different parties. In order to overcome this problem, most often now what we do is we recommend a down conductor system usually made of GI tapes bonded or clamped to the steel reinforcement. There are several advantages of doing that. Now you don't have to worry about this 50% welded or securely bonded and 20 times the diameter overlapping. Instead, you are getting a down conductor system which will properly conduct lightning current. What are the advantages? It's unlike an external down conductor, this is not seen to the outside. So it is aesthetically good. No problem with the appearance. Then the current conduction is now much better because apart from the down conductors, these are clamped to the steel reinforcement system. So there are thousands of current paths so that the current through any conductor will be extremely small. Third advantage or fourth advantage, theft proof. Nobody can, copper theft is a big problem in many countries. Now that is solved. And the last advantage, there are many other advantages as well, but last key advantage is it is cost effective because you are not using copper, you can use GI. Okay, but don't use aluminium. Aluminium is not allowed to use inside concrete in contact with steel. So this is one real case of that. And this is how it will look like. From the top, you connect it, the air termination. Air termination should always be outside. Huh? It is connected to the steel reinforcement. Then from down, it is taken out again to be connected to the earthing system. Then let me show you a few pictures. These are where the metal facade is used. And also be careful. This is one problem you are having if you have steel roofing and then you put an additional copper tape as your air termination or down conductor, then you will find that the roofing material will corrode very fast because of the galvanic effect. So that having natural component will solve you that problem as well. And then this table is very important. When you are using different materials, make sure that they are compatible. If they are not compatible, one best way is to use stainless steel to buffer them so that they will not have contact between non-compatible materials. And the final one, the ground, when you are using the steel reinforcement of the foundation as your earthing system, in USA they call it UFA ground. It is named after a defense guy whose name was UFA, who lived in the 1950s. So here I'm going to show you some examples. What you have to do is when you are laying the foundation, so this is the foundation of a steel tower for communication purposes. The you have to take the electrical connectivity of the steel structure out of the concrete and keep it to be used as the earthing system. And again, if you are not sure about, don't forget that in this case also, this three conditions set forth is applicable. So if you are not sure that the civil engineer will adhere to what you are telling, then you can have an extra steel or galvanized steel tape system connected additionally into the steel reinforcement, and few pictures you can see here. Then just to save time, I will just go through these pictures where you can use, for an example, for this building, you do not need air terminations or down conductors. Roof you can use as the air termination. Steel struts that you can see can be used as your down conductor. And earthing system depends on the foundation. Usually for this type of buildings, the foundation is not very solid. Therefore, we recommend connecting it to an external earthing system. Few pictures. And is my time over? Nearly. Then let me show this and stop. This is not actually natural component, but whenever you are having big problems in achieving earthing, one of the best methods that we have practiced and proven is to have concrete earthing. So actually this was very extensively given in BS 6651, and this standard is now suppressed. Not much research has been done for the last few decades in this regard, but we are now doing it. You can use a steel reinforced concrete chunk as an earthing system. And we found that when the resistivity is this much, in order to get less than 10 ohms, we can use this table, but still we are conducting some research on that. And maybe next year we can publish a journal paper in this regard, giving very solid recommendations. I have been doing this in Malaysia for the last 10, 12 years. And when I came to South Africa, I started working on that. But still we have some doubts, so we continue our research. These are few pictures from Sri Lanka where they have used the concrete earthing. And these are some work we have done in Malaysia. This is my own research. And then I will skip this slide. This is a story about a grounding system we have designed in Mexico for a problematic pathological tower site, but I don't have time to go into that. It can save you a couple of million US actually if you do it properly. And this is the general guidance for the selection of material for earthing systems. Thank you.
What's the issue now? So, may I start? Good afternoon or almost evening. I have about 30 minutes or probably 20-25 minutes to talk to you regarding electrical safety. So Dr. Chandiba made a short presentation on lightning protection. Normally his class on lightning protection takes 3 days. This 3 days subject has been skewed to 30 minutes. This was quite interesting to listen. So I am also trying to skew a big subject into like a capsule. So my name is Gopakumar. I am a member in the International Electrotechnical Commission for electrical safety, for lightning protection and so on. I have a company in India, Cape Electric. We are mainly electrical safety in low voltage system. So when we talk about electrical safety, there are so many people to speak, but mostly the engineers talk about electrical safety in the high voltage system, transmission system, distribution system, power supply system on the roadside and all. But what we concentrate is inside your house, inside an industry, which is very much important. Why this is important? I'm sure you must be seeing these kinds of news every day in the newspaper. I don't follow the newspapers in Nepal, so I don't really know the situation. Whereas in India, this is quite common. Almost daily 3 to 4 accidents, and we have so much population, so people stopped counting it really. So, daily such accidents are happening. A Japanese delegation in 2016, they made a study and presented a paper in front of the Government of India, of the Power Ministry. In the seminar, they presented this paper. And it says, out of 100 million population annually, about 723 people die in India due to electrocution, only due to shock. So means on an average about 10,000 people die every year. But the fact is, most of the accidents, only 50% of the accidents are reported, and this is the reported figure. So actual figure may be much more than this. So to put it short, hundreds of people are dying, animals are dying due to electrical reason. But when we talk inside a house or inside an industry, it's majority people. Lot of accidents are happening, and the same study, they made a survey and published what is the safety score per country. You also look at the score here. One moment. See, this is India, 723 persons out of 100 million per year, and in Japan it's 12. And the graph is, you can see how higher, our house, very poor, or how poor our electrical installations are. Similarly, they made the study and made a score, safety score, out of G20 nations. India got the least score, 16%. I'm sure the situation in Nepal is also almost similar, because most of, we share the same culture, the same system, and the things are copied from India. I show a video, but don't get shocked. It's a video from the YouTube. This is a hospital and an ICU. You have to look at what is shown on that circle. It's an ICU. The people are there on the ICU. It's a COVID ward. During COVID, what has happened is, they found some problem in the machine. They are trying to take the patients out, and there is the smoke already started, and the equipment started burning. And actually, after 1.5 minutes, this room is full of smoke. See, See, it's already burning, and there are patients, and they are helpless, and they don't know what to do. You see. So basically, electricity is a danger if we don't use it properly. Electricity is the lifeline of building, but it is equally a danger. Okay, let me skip it. In India, during the COVID time, there were about 24 accidents and more than 124 people died in hospitals alone, especially in ICUs. Now, for electrical safety, what do we follow? I'm sure in India, what we were doing is some technical subject we take from Britain, something we copy from America, something from Germany, and then we make a mix of all the things and put it into, wires are of this type, MCBs are of selected based on something, motors, something. Then we make a mix and finally things won't work. So Nepal is a member in the United Nations as well as in the World Trade Organization. Nepal is a signatory to TBT agreements called as technical barriers to trade. That means, worldwide, every nation should use a common standard for the purpose of safety, for the purpose of trade or services, common standards. And those common standards are ISO, IEC, ITU. So what I wanted to tell you is, don't try to copy something from Britain, something from other nations like America. You take a few lines from an American standard, a few lines from a British standard, a few lines from German standard. Don't do it; it won't work. For safety, ISO, IEC, and especially for electrical items, there are established IEC standards available. You won't believe. There is a standard for mosquito repellent light. Mosquito repellent, you must be knowing, no? This on the shops we used to put the mosquito repellent. For the light, there is an IEC standard. So standards are and practices are there for even to that small subjects, but we don't have the habit of looking into what is written and what has to be selected and what has to be installed. Then what do? For example, lightning protection. We have seen in lot of buildings in Sri Lanka. There is a story. There is people call as advanced lightning protection system. One rod will attract lightning from 100 meters. So not only you, all your neighbors are protected. Then there is one down conductor and one earth electrode. The claim is, people even say the whole town is protected, the whole village is protected, and then they say this is according to the French standard. Actually, there is a French standard. It's very funny to understand what the French people have written. So there is a French code. I am just showing you the actual French standard here. The French code, if we read, it consists of all these items, serial number 1 to 18. There are so many things required in order to protect your building from lightning. The first item is the rod, which is placed at the top of the building. If you read the IEC standard, everything from serial number 2 to 18 is required. Remember, everything from serial number 2 to 18 is required. In the French standard, they have added one more item, which is a rod. And with this French code, because we don't take it and we don't read it, we just believe the catalog of the manufacturer. With this standard, what they actually sell in the market is like this: one rod, one down conductor, a small PVC wire, and finally one earth electrode. But what is written in the code or written in the standard is totally different. So what I wanted to tell you is, it is always best or good to follow the IEC standard if there is no national standard available. Now, India is a member of IEC and all the standards, the safety standards in India nowadays, we are going very fast and a lot of upgradations are happening. There is a National Electrical Code. Probably in 2 months, you can see the National Electrical Code. And for your information, the Indian standards are now free of charge. You can download free of charge, but don't give your address, Nepal address. You give some Indian address, so it will get it free of charge. And these standards are highly, actually, if you buy the IC standard for lighting protection, this is example 30,000 Indian rupees. But you buy from the Indian standard, which is exactly the copy. It is, I think, 2,000 rupees. So that much. Now, in India, electrical safety, there is a big subject going on, earthing. People always wonder, electrical engineers always wanted to do earthing as per a standard called as IEEE 80. I'm sure if electrical engineers are there, you will understand it, IEEE 80. First point is that is not a standard, that is a guide. It's a guide. So it's not a mandatory requirement. It's not a recommended practice. It's just a guide. And that guide is applicable because the distribution system in America is different than our nations. We have the low voltage distribution. They have the HVDS, high voltage distribution. A substation means which is feeding a high voltage distribution system, and they apply the techniques in this guide to reduce the touch and step voltage. That means shock voltage reduction. Whereas we take the same standard and apply it for the low voltage transformer. Because this standard has never written the definition of substation. So we think a transformer on the roadside, the small transformer is a substation. That is actually, according to Americans, that is not substation. That is, basically what I wanted to tell, the message what I wanted to tell you is, electrical safety is a critical subject. If we try to mix up the information from different sources, we are in trouble. Also, don't believe the technical information in the manufacturer's catalog, because manufacturer's catalog, what is written is helping to sell his product, not to improve your safety. In the market, especially in India, there are some gadgets available. It's a black box. It's a box, metallic box. They say this is an IoT-based device. It will offer protection in your building, protection from overcurrent, short circuit, and all these, this red color I have put, surges, transient, everything is protected. In one of the hospital, this kind of a device is installed. Then I happened to see that, and then I asked what exactly do. Then the engineer who installed it, he told, as soon as there is a problem, you get a shock. As soon as there is a problem, you get a SMS, IoT, SMS. Then I asked him, okay, but before I get the SMS, the person will die. Because somebody is getting a shock. Person will die in few milliseconds. So, what is the fun in getting an SMS? So, such kind of lot of magic things are there in our nation. Don't believe in magical devices which offer you all kind of safety. There is nothing. Like for electrical safety, you must follow the science. You must follow the fundamentals. So, for example, in India, we say the regulation 12, which is recommending to follow the code of practice of India. If there is a lack of knowledge or lack of information, you can very well follow the Indian standards, which is exactly from the IEC. Some modifications are made, but which is suited to the Indian climatic conditions, which is of course similar in your country. One of the major electrical safety subject is called as system earthing. Electrical system, the way electricity is brought from the transformer into your building, there are different types, which is called a system earthing, TN, TT, TNC, TNCS, so a lot of things are there. But most of, a large number of electrical engineers, they heard their name, but most of the time they don't know how to achieve safety in a TT system, how to achieve safety in a TNS system. Because the way of achieving safety is different depending upon the system. Another point, electric shock. Every electrical installation need protection against electric shock, protection against thermal effect, protection against over current, and protection against over voltage. These are mandatory. When we talk about protection from electric shock, the first and the fundamental safety measure which is required in every building is you must connect all metallic parts in your building. Every metal part like metal water pipe, metal gas pipe, motor body, panel board body, metal rebar if you can. You have to interconnect all the metal parts. Now, the phase and the neutral wire you cannot directly connect. There you have to use a device called the SPD. So that whenever there is a problem, the entire building acts like one piece of metal. There is no potential difference between each and every material or each and every metal part. If we are able to achieve a very good equipotential bonding, then the building is safe. The first fundamental safety measure is called as equipotential bonding. Means every metal part must be interconnected. But did anybody saw a building, a steel building or a large building in Nepal where the rebar is connected to the earthing system, or for example the metal pipe is connected to the earthing system, or the air conditioner ducts are connected to the equipotential bonding system? Actually, in most parts or in our nation, these are actually quite new. Even though these are there on the rules for the last 50-60 years, we really don't follow it properly. Danger. Another subject is disconnection. You have protective device, and those protective devices, such as, for example, MCB, ELCBs, or the arc flash detection devices, all these protective devices are supposed to operate within certain time. For example, an MCB. Here, in a circuit, this one, the final circuit, that means the air conditioner is connected to a socket here. In case of any problem in this air conditioner, what kind of problem can come? Yes, of course, if there is an insulation failure, it can create an arc. As I shown you the video of the fire from the operation theater, annually approximately 200 air conditioner fires are happening in India, and again, a lot of people are getting killed. Because recently there was a case in Kerala, 5 people in one family got killed. Only the air conditioner, 2 air conditioners blasted, and the wiring got burned. They have not died because of the heat or the fire, they died because of the smoke. So smoke is indirectly the killer, but from where it starts from the electrical apparatus. So disconnection time, very, very important. Now for disconnection time, your MCB will not trip just like that. The MCB has got certain characteristics in the sense, don't think that putting an MCB, it will trip. No, you have to have each and every protective device have got its own characteristics. The characteristics of the device and the wiring system must be coordinated in such a way that these devices are able to do its job. Very important. But so for that, how many electrical engineers are there here? Any electrical engineers? Yes, few. Oh, lot. An MCB, there are 3 categories of MCB: type C, type D, type B, C, D, 3 types. And these MCBs have got a certain current to trip within a specific time. And that particular current, say for example, a type C MCB, 10 times, like I have put here. So here, type C, 10 IN, that means 10 times current is required to trip within 0.1 second, because whenever there is a shock, the MCB should trip within this particular time. And now for tripping this particular, disconnecting the fault within this time, there is a parameter called fault loop impedance. Let me see whether I have the slide. Actually, I hid the slide because I didn't thought that a lot of engineers are there, but I can show it. This parameter called as fault loop impedance, here. Fault loop impedance means whenever there is a fault, here there is a fault, the fault current is supposed to return back to the source, and then there is a loop. The impedance of this loop decides the amount of the current, and then the current decides the disconnection time. Very, very important, or probably one of the first electrical fundamental things. Fault loop impedance, and there is a meter available called as fault loop impedance meter. So after installing the MCB, we are supposed to check with the meter. Have you ever heard of this word fault loop impedance? Any answer? Don't. I'm not trying to put you in trouble. Please make an open answer. The idea is to improve the system. You have heard. Thank you. Now, have you tested this particular thing? There is a meter available called as fault loop impedance meter. You have two techniques. So one is you can calculate the total impedance. Then every year or maybe probably once in 3-4 years, you can measure it with a meter, which is actually mandatory and it is included in all the technical books. Unfortunately, rarely followed. Then, there are several subjects if we talk about electrical safety. I will skip most of them. I will straight away go to a subject which is testing. All of you know that a high voltage line or a substation, during commissioning, a lot of tests are carried out. Similarly, for low voltage installation, in a high voltage installation, even if there is a fault or even if there is a problem, only skilled people are going to be inside. The engineers or the technicians are only going inside a substation area, whereas in a house, normal people and even children are there. So it's highly important to carry out the testing of every electrical installation. There are about 19 inspection points and there are about 10 tests which are included mandatorily in the Indian standard. Of course, in India also nobody can do it. But nowadays in the regulation, we are writing that, if the building is not tested, tomorrow if something happens, accident happens, there is no insurance. You cannot claim. The insurance company will not pay. So indirectly, people are forced to do the testing and such things are coming up. I have put one more, the last one, PAT. In Europe or in Americas or Australia or developed nations, they even take one more test. It means it is called as PAT, portable appliance test. Say for example, you have a very good wiring. So you have tested your wiring, you are sure that your wiring is perfectly alright. Now tomorrow you bought an air conditioner like this, and this air conditioner you are plugging to the socket. Up to the socket it's good. But once when you put this kind of a portable device or a socket connected device, you don't know the condition of this air conditioner and probably this can catch fire. Even if you have a good installation, probably it can create a fire or an accident. What do? There is a test called PAT. PAT stands for portable appliance. It's a portable device or small electrical device, There is a meter available. We are supposed to put the socket into the meter, then it automatically diagnoses the appliance and it gives a certificate or it gives a green sticker if it is good. If the equipment is faulty, it gives a red sticker. So in Europe and all, if you go to a shop to buy, say for example, a mixer grinder or something like that, some electrical appliance, in front of you they will do the test. The shop owner will do the test and they will take the sticker and put it on the in the equipment. You can connect that particular appliance only if it has got a green sticker. Otherwise, you cannot connect. So electrical safety is a subject where people are going so seriously, whereas in our nation the seriousness is quite less. So what we are trying to start some large campaigns to increase the awareness of the electrical safety and to make the nation safe. Thank you very much.
Thanks so much. Do you have any question? Any questions? How many sir? Please answer question, sir. Online मार्फत तो कैसे question आसे ना?
Thank you for a nice lecture. I'm just particularly asking regarding the solar mini grid. You talked about this equipotential bonding.
Yes.
So can we have one earth termination system for lightning protection system and protective earth and all the body earthing of inverters? Can we have only one earth termination system?
Yes, actually that is what is included or recommended and practiced. I will just show a picture. One moment, please. But what is practiced is different. What is written and what we are trying to make is, just a moment. It is actually all connected together. The DC system frame.
Yeah.
Then I think it is easy to explain it with the. Yeah, I am showing one moment. Yeah, I have made it. I think solar is a hot subject here, right? So how you should make these connections are so this is considering a power supply called as TNCS. Here you have the solar panel frame which is connected to a common bus bar, and this bus bar is probably very closer to your solar PV junction box, the combiner box, if you have one. Then near to the inverter you have to have a bus bar. The whole connections actually comes to the common bus bar, and then it goes to the main bus bar of your building if it is rooftop. Then it goes to it is actually not earth electrode here. The symbol, the meaning is you have to make shock reduction measures.
I didn't see the lightning protection here.
Yes.
SPD
Now,
only.
yeah, I'm showing. Now, if you have a lightning protection system, from this bus bar, you have to extend a connection to the lightning protection system of the building. There are three ways of making lightning protection for a building for solar. The first concept is no lightning protection, means the lightning can directly hit your solar PV and it can destroy, which is actually technically accepted because sometimes spending money for lightning protection system is not worth because your building height is maybe smaller. So this is one of the method. The second is you can have a lightning protection. Here there is a calculation required. Separation distance means the solar PV panel and the lightning air termination is a little bit away, physically away. So in that particular case, the most important point is you are supposed to select devices called as SPDs like this. Now you see the down conductor coming and finally it is connected to the bus bar, the common bus bar. The second is, the third is without separation distance, you can bond the lightning protection into the structure of the solar PV. In the other sense, the structure of the solar PV can be used as a part of lightning protection system. That is also allowed. Only thing is, in that particular case, you have to select the SPDs appropriately. Lightning protection system and the selection of SPDs has to be coordinated in such a way that under any circumstance your balance of the plant are protected. So different techniques are there. This technique is used, for example, there is a down conductor which is shielded. So these techniques are there, but we can also send you this information, explaining this in 10 minutes or 2 minutes will be difficult.
One more.
Basically, you have to interconnect everything together. There is nothing like the solar, near to the solar panel, you put a rod and connect it to a separate earth pit. The frame you take and put it to a separate earth pit. Inverter, you take a separate connection to the earth pit. That is not there.
One more, sir. How effective is the EAC type LPS versus just simple lightning rod?
Can you answer?
The cost is very, EAC type is much more expensive, probably 20-25 times expensive.
Okay, now let me give you a very brief idea because this is another 2-hour presentation. Actually, the ESE, which is, I think Mr. Gopal showed it in 1 or 2 slides, is a method which is accepted only in French standards and then Spanish standards. The whole world has rejected it. IEC, NFPA 780, Australia, New Zealand standard, South African standard, everything has rejected it. The reason is that when we are adopting a system for protection, now we are installing a lightning protection system for the protection of the building. Whatever the gains of this, if it is not giving protection, then it is worthless. So now, as Mr. Gopakumar correctly pointed out, ESC according to the French standards and ESC, what is practiced in our part of the world, is somewhat different. Here you will find that most often they say you install a rod, down conductor, and one earth. I'm a Malaysian permanent resident. I lived in Malaysia for 10 years. And we have seen more than 1,000 buildings where ESC devices are installed and hit by lightning. The reason why we see such buildings in Malaysia is that Malaysia is one of the most lightning dense countries. So, coming to your question, my advice is effectiveness of ESC devices is not estimated. You can't tell it. If I tell you an ESC device is this much of effective, then I will be able to tell the same for just any rod, one down conductor and one earthing system. I don't see any difference between ESC rod, down conductor and one earth pit, normal rod, down conductor and one earth pit. Any difference between that? So if this one is hit by lightning, that one will also be hit by lightning. And finally, what I have to tell you is that when we are introducing a new technology, we are not against new technology actually. We are, to be honest, in the field of lightning protection of structures is one of the least developed technologies in the world. Still we are using what Franklin invented 300 years ago. So we are looking for some new development, but unfortunately the answer is not ESC, because the ESC technology is not proven technically, that is experimentally, theoretically and statistically. So any technology which is introduced afresh should either be tested and proven experimentally. You have to do an experiment and say that, okay, this is the thing. Or theoretically, from the first principles, you have to show that this is the case. Or statistically, you take 20,000 buildings. Say that in these 20,000 buildings, there are this many ESC rods, no lightning damage. There are 20,000 buildings where there are normal rods and this many damage. So nothing has been done. That's why we say that don't go for that. It is really dangerous. It is dangerous.
Not still in utility scale.
Yes, of course. This is what we are fighting for. But Malaysia is the first country in the world which banned ESC. There is a government.
India is the second country. India is the second country.
I visited Bharat.
Yes. Okay, great.
Because even in 200 megawatt plant, I saw ESC in India. 200 megawatt.
Solar plant.
Yeah, Bharat plant.
Yeah. In India, in the National Building Code, we have written not to use it. It's not recommended.
Just an information. As I told you, I am representing or chairing South Asian Lightning Network from Nepal. We have been conducting various online programs, inviting the experts from the global experts from around the world. This 14th of June, we have another webinar of the series. That is the expert being invited in that is Mitch Kutere, who has been the former president of chairman of TC81. That is the technical committee that is making the standards on lightning protection system. So he is the key person, our speaker of the next program. So if you would like to join with that, you are welcome. You go to the Solnet's Facebook page there. We'll provide the link and so on. This is just for your information. If you are interested, you are very much welcome. Thank you.
Additional question, please, somebody.
I want to ask one question. Thank you for being Professor Chandima and Professor Gopakumar. It's nice being. So actually, I would like to ask, mostly in building cases and or electrical installation cases, why whatever that is investment that is done, I think electrical portion, I think 10 or 20%, I think so. And in that 10 and 20%, hardly 3 or 4% that is the protection issues that is implemented on that whole scenario. What is happening here, or I think in South Asian region, suppose the investment that is done for building or industry installation, most part that is accommodated for building civil structures like that. An electrical portion that is very limited, and almost all the things that investment that is spent on large civil structure or other structures. So what the protection you have saved all that initial stage, right? Whatever
One time.
installed one time.
One time.
But mostly the cases that is occur that is after some time. That is insulation breaker, insulation that is failure,
Yes.
that is hitting on the insulations. So once that is happened, so and finally that is the occurrence of fire or accident, major accident. So we are only aware of that, right? But in between, if you have an IoT or SMS systems, whatever the technology, if that is suppose degrading insulation, other things, protection issues, if that system is aware that the owner, so that will be fruitful. So you have any idea so that people will aware, okay, right? If that is some protection issues, that material that is degrading, so be aware of that because it's 10 or 20 years. That is.
Yes, I got the question. So that is why I told you the testing. Every electrical installation, before putting it into service, we are supposed to make a testing, not one test, a series of tests, 10 tests. Then, depending upon the type of your application, maybe residential, maybe office, maybe a data center, a telecommunication center, you are also supposed to do periodic testing. Say, for example, hospital, ICU, group 1, group 2 medical locations. Every year you are supposed to do this testing. In a residential house, probably every 10 years you can do. In an office complex with a lot of people, probably every 2 years you are supposed to do periodic testing. If you are doing the recommended periodic testing, you can find out the faults, probable faults very well in advance and you can rectify. But the question is whether we are doing it.
Can I add up something?
Yeah.
Actually, now if you take South Africa, for many institutions like hospitals, schools, and many places of public gathering, they have made compulsory an electrical safety auditing every 3 years or 5 years, and in some cases like hospitals every year. So this is one way of people ensuring that electrical accidents will not happen. Okay, because South Africa is one of the countries with the highest number of lightning accidents per year, so that they are now taking very strict policies on that. I think just to address your question, I think I understood a part of your question. Now there are many indicators coming with electrical systems. For an example, recently Schneider has developed MCCBs where the level of degradation of or lifetime of the MCCB is coming to the telephone, so that it is not for whenever there is something wrong it is coming. This is periodically it says that now this is the condition and so on. These things are coming up, but I don't think Schneider has introduced that into the market yet. So these indicators are now coming up with electrical devices.
Now also please understand that there are a lot of condition monitoring systems available. All these systems will work if you have a good electrical installation. For example, if you have a TNS system, you make a proper TNS system, then it will work. But half of your building is TNS and half of the building is TT, it won't work. Unfortunately, for example, I am sure you are aware of UPS. A lot of you, we have the habit of using UPS. And we also have the habit of UPS earthing. Correct? Sometimes from the UPS a separate wire is taken to the earth pit. Actually, it's a bad practice. If you do in that way, at the output side of the UPS, even if you have some monitoring, it won't work. MCBs won't trip. Finally, you will end up with trouble. So, the fundamental is first you have the basic electrical system, which has to be strong. Equipotential bonding has to be strong. Over and above, if you have any kind of monitoring, it actually improves the system. But if the fundamental itself is wrong, then the balance won't work. This is actually from the experience from India, because the situation in the developed nations are quite different than our case. For example, training of electrical engineer. Most of the electrical engineers working in India, okay, before that in Britain, in British there is a wiring regulation called as BS 7671, British wiring regulation. Whenever there is an upgradation in the regulation, almost all electrical engineers go for training. They go for training and finally they get the certificate, and only with the upgraded certificate they can work in the electrical installation, either designing, erection or testing. Whereas in India, if we ask an electrical engineer, 25 years experienced, from where did you study? No, when I joined this company, my boss told me, and whatever my boss told me, he is my guru, and whatever he educated 30 years back, I still follow it. So, but people don't understand that the systems had changed a lot of improvements had come. So, we are not adaptive to this, the changing world, fast changing world. Unfortunately, electrical engineers are the only engineering community in India, those who were not trained well, still following the advices of the gurus. And who is the second person who educate or give the knowledge to the market? It is the equipment vendor. Wire manufacturer will explain about wires. MCB manufacturer will explain about MCB, and we always go for the modern things like a microprocessor based disconnecting device, microprocessor based MCCB. A normal fuse also does the same job. Both the things are not going to protect if your fault loop impedance is not there. Are you testing the fault loop impedance? No. So your fundamental is wrong. So this is what I wanted to do. Thank you.
Actually, mostly what happening is that suppose in testing stage, if there is some fault or without fault, if suppose ELCB that is placed in building, right? And in testing phase, suppose there is fault, and ELCB that is finding very small faults. So what is the happen? Actually, if in testing time that ELCB that is disconnected from that is the main thing. So because in testing period if that is tripping the systems, so mostly that parts what is happening in real practice, if that protection system hampering all the systems, so that system actually that is disconnected from the protection lines. So that is happening actually. So that is a serious issue.
Yeah.
Most of the cases.
Electrical system must be installed, designed, selected, and erected, installed in such a way that
that is also a system.
it has to ensure continuity of supply as well. Nuisance stripping is not accepted. If you have ELCB and if it is tripping because of you are doing a testing, or it is tripping because of somebody is making running a welding machine, that is also not accepted. So equally disconnection is required, equal importance is given for continuity of supply as well. And if the installation is not correct, then it will create nuisance stripping. As you said, in a good installation, of course, it won't. So I hope there is no other question. Yeah.
I have one question regarding lightning protection system.
Yeah, Professor Chandima.
Okay. I have a still water tank in my terrace. It's a 2-story building, and I have kept a conventional copper rod air conditioner above 6 meters from the terrace. Now, should I need to connect a down conductor to the still water tank stand, or not? Is it safe or not?
You have the steel water tank.
In my terrace.
Okay. And then
I have
it is floating?
No, it's with a stand, iron stand.
Iron stand. The iron stand comes all the way down.
The terrace. No,
Okay.
it's above terrace.
Okay, this is a problem. Now we call this system a floating electrode because you have the water tank. It is just placed on the iron stand, and then again this contact may not be very good. Then this iron stand is on a floor, concrete floor. So this is a very dangerous situation. Okay, the reason is that when you have such floating electrode system, it can intercept with the lightning much easier than other parts of the building. And then after the interception happens, there is no safe way for the lightning current to flow into ground. So there will be arcing all over. So you will find that there are very many damages if lightning strikes. So two things. One thing is try to bond the water tank electrically soundly to the metal stand. This is one important thing. You better connect it at least at 4 places. Second thing is your metal stand should be connected to a good electrical earthing at the bottom where it is standing on the concrete. So if you do these two things, then it is safe.
Okay, sir. And is there any reason between steel tank and plastic tank?
Yes, because plastic tank, if you have a plastic tank, then it will not intersect with the step leader. Okay, so if you have a plastic tank on the metal stand, then you can't expect the tank to protect your building or anything because the plastic will not be safe in the event of a lightning. So one thing that you can do is you protect the plastic tank with air terminations. But I can't tell you exactly how the calculation is done. We need time. And then you have the stand, then the water tank. So you will have these air terminations, either 1 or 2 or 4. And then the metal stand can be earthed just like in the case of having a metal tank. Okay? So if you don't have these air terminations, then what happens is that in the event of a lightning, your water tank will be blasted. So this is why we need air termination.
You mean to say that if I have a steel tank in my roof, then I have to give a separate air termination system to be connected to ground?
No. I told that if you have a steel metal tank, if the thickness, most probably in metal tanks, the thickness satisfies that 0.5 millimeters. Otherwise, you can't hold the water. So therefore, you can consider the tank as the air termination. So connect the steel tank into the metal stand properly, then the metal stand ground properly. That's it. Instead of the metal tank, if you have a plastic tank, then you should provide additional air terminations to protect it. The rest of the story is the same.
In case of steel tank, during the case of lightning, water is also a conducting thing. Okay.
Yes.
Will there be any effect if I go to my restroom and use the water at
No, the thing is
will there be
that
any effect?
if you have properly earthed your tank, the current that will come through the water is negligible. Maybe you will get a little tinkle if you are taking a bath. But if you have not earthed it properly, then you may get a severe shock. Okay? Yeah.
Communication tower. Communication tower like I think in the previous lecture, I think 2 years back, he told that it's better to use the tower itself as a down conductor instead of using a separate copper wire. But say for example, at some time the earthing resistance, earth goes dry, and when earthing resistance is bit high. Then in that case, isn't it possible that the tower potential during the lighting increase for some unsafe voltage and going to the communication equipment? In that case, the separate copper wire will be separate.
Okay, now the thing is this. It's nice to see that somebody who attended my previous workshop is here, so I can't tell lies. People repeat. Okay, what I told is that for the steel towers, usually the telecommunication tower protection we do according to ITU standards. And the ITU standards very specifically say that if you have even a pre-painted tower, you do not need a down conductor. But you need a very good earthing system. Now your question is actually not relevant to what you are asking, because whether there is a down conductor or not, if your earthing system is not good, then we'll have a rise in potential. So that down conductor is having no effect at all. Did you get my point?
But it will be isolated from the tower. So
Oh, this is something very dangerous. Now, if you are taking isolated, insulated cable from top to bottom of a tower, then you are in a very dangerous situation. Okay? Because if I had a board, I could have easily shown you with a very simple equation. If you apply V equals IR plus L di by dt, then you will find that when a conductor like a copper tape is injected with lightning current, the voltage gradient due to the IR term is few volts. But due to L di by dt, you get something like 80 kilovolts per meter. So that means if your tower is 20 meters tall, you get 1.6 megavolts along the cable with respect to the ground at 20 meters. And now imagine that you have a tower which is well earthed, and you are having an air termination insulated cable coming down. And if lightning strike this, at 20 meters above, this copper tape or whatever the insulated cable will have 1.8, 1.6, 1.7, maybe 2 megavolts, but your tower is at zero potential. How much insulation you expect to prevent arcing from 1.6 kV, 1.6 megavolts to 0 volts? So what happened is that if you investigate, I could have shown some pictures, because I have taken some photographs of many such cables, insulated cables, put on these towers. After about 40-50 meters, every insulator is split open. Sometimes it creates fires. So therefore, don't go for insulated cables for towers, especially metallic towers. Don't go for insulated cables for any other application unless there are two conditions. One is if your conductor is in contact with another metal like a roofing material, then in order to prevent corrosion you need insulation. Second condition is if there is a chance of somebody touching the down conductor in the presence of a lightning current, that part should be covered with insulation. Other than that, we are not recommending using insulated cables at all. Got that point?
the tower, maybe the inductance of the tower itself is lower than the single copper wire, but in that case also you mean to say that the tower, the GI by dt, the communication equipment attached to the tower, it's a top portion, and say kilovolt, in that instant, in that point, the potential of the tower is kilovolt, and potential of the communication also kilovolt, so equipotential, no problem.
Wait a minute. When you are now we are going to another domain, the protection of towers. Now, in the event of a lightning to a tower, whether there is a down conductor or not. Actually, I have done some research in Sweden. We have used a prototype tower and a down conductor, and without the down conductor, we applied the lightning current into the top, and we found that only 2% of the current flows in the conductor. The rest goes in the tower. So whether there is a down conductor or not, the current will come to ground, and due to the LDI by dt of the tower plus IR of the grounding system, it is unavoidable that in the event of a lightning strike, at the cable trunk level, the potential will be in the order of 12-15 kilovolts, even if you have the best earthing system in the world. Okay, that is why we always say. So what does that mean? Your entire earthing system, power earthing, communication earthing, everything is at 12 kV. Therefore, in order to prevent damage, you need to go for a proper surge protective device system. So when you connect your communication line, data line, all the signal lines through SPDs to the earth, your power line through SPDs to the earth, then in the event of whatever the lightning, even if the potential rises to 200 kV, your system is safe. However, we ask you to keep a low potential on the earth, at the tower side, by having a good earthing system, not to protect your equipment. If you have a very good surge protective device system, your equipment will be saved. However, when the potential rise happens, if you have a transformer which powers your tower, and the same transformer is providing power to other utilities or other places, then when the SPDs operate, this high potential will be transferred to the neutral, and through the neutral it goes to the transformer, and then it tries to earth through the transformer star neutral point. But if the transformer earthing is also not good, then this high potential will appear in all other buildings, and one unfortunate guy will have his panel get exploded or his equipment get damaged. So this can be minimized if you have a good earthing at the tower. So this is why in Sri Lanka, for an example, before I left Sri Lanka in 2009, we came up with a national policy which says that all tower owners should ensure that there is a certain maximum earth resistance at the tower site. But even with that, we had some problems. So then I recommended that tower owners should provide surge protection to the buildings or other houses around, which is being fed by the same transformer. The house may be 2 kilometers away, but still if it is fed by the same transformer, when the tower is hit by lightning, that house may get equipment damage. To me or TK? Okay.
Is it okay to learn non-conductor from corporate government center?
Okay.
Last question of informal discuss garnलाई time पनि भछ.
Now this is actually a practical issue. So usually we say that down conductors should not be taken through concrete ducts or any ducts due to two reasons. One reason is in the event of lightning current passing, if the conductor is in very good condition, no problem. But if the conductor is damaged, then you never know what's happening inside, and the lightning current may cause an arc at the weak point. And if an arcing happens inside a duct, there is a very possible chance of explosion. So therefore, we say don't take the down conductor through somewhere where you cannot inspect it. But there are some cases where we have no other way to take the down conductor but through a duct. Then we allow it because the standards do not make very strict prohibition on that. But we say that every 6 months at least, you check the conductivity top to bottom of the down conductor and ensure that the total resistance is less than 0.2 ohms. In that case also, if that duct is providing the path to power lines, communication lines and so on, then we say don't use it. Okay? So that you can take the down conductor through a duct, but make sure that there are no other service lines share that same duct. Okay?
Okay, thank you. Now time is already over, and you can put your questions during informal discussion. Okay.
Thank you so much for our special presentation from our special guest. हामी कार्यक्रम अन्तिम चरणमा छौँ। नेपाल इन्जिनियर्सको यो टकसो प्रोग्राम निरन्तर रूपमा गरिरहेका छौँ। यहाँ उपस्थित सम्पूर्ण इन्जिनियर महानुभाव, यदि इन्जिनियर्सको मेम्बर बन्नु भएको छैन भने हाम्रो वेबसाइटमा अनलाइन मेम्बरसिप लिन हार्दिक अनुरोध गर्न चाहन्छु। साथसाथै आउने फ्राइडे पनि हामीले इलेक्ट्रिक सेक्टरकै एउटा प्रोफेसर, नेपालकै प्रोफेसरको रिनाउन्ड प्रोफेसरबाट प्रेजेन्टेसन राख्दैछौँ। मलाई आशा छ त्यसमा पनि तपाईँहरू उपस्थित हुनुहुनेछ। अब हामी कार्यक्रम अन्तिम चरणमा टोकन लभ वितरण कार्यक्रम छ। टोकन लभ वितरणको लागि हाम्रा केन्द्रीय अध्यक्षज्यू लगायत महासचिवलाई पनि अगाडि आइदिन हार्दिक अनुरोध गर्न चाहन्छु। साथसाथै आजको गेस्ट प्रोफेसर डाक्टर श्रीराम शर्मा सरलाई पनि अगाडि आउनु र टोकन लभ स्वीकार दिन अनुरोध गर्न चाहन्छु। I like to request to our guest to receive our token of love, Dr. Professor Chandima Gomez. Again, and let's go past. So much. This is very Professor Dr. Sriram Sarma sir. धेरै धेरै धन्यवाद सम्पूर्ण सरलाई। हाम्रो यस कार्यक्रम फेसबुक लाइभ मार्फत पनि हेर्न सक्नुभएको छ। साथसाथै युट्युब, हामीले यसलाई युट्युबमा पनि हाम्रो अफिसियल इन्जिनियर्सको अफिसियल युट्युब च्यानल मार्फत नै हेर्न सक्नुहुनेछ। अब कार्यक्रमको अन्तिम चरणमा छौँ। हामीलाई यस कार्यक्रममा उपस्थित भई यस हलमा यति रोमाञ्चक तरिकाले उपस्थित भइदिनु भएको छ। साथसाथै फेसबुक लाइभ मार्फत हेर्नुहुने सम्पूर्ण इन्जिनियर तथा म धन्यवाद दिँदै आजको यस कार्यक्रमलाई समापन गरी थोरै मन्तव्य राख्दिन हार्दिक अनुरोध गर्न चाहन्छु र म पनि हजुरबाट बिदा हुन चाहन्छु। हस्, धेरै धेरै धन्यवाद।
Thank you, Saroj. Respected presenter, Professor Dr. Sriram Sharma, Professor Chandima Gomez, Engineer S. Gupta Uma, NEA Executive Committee members, senior engineers, colleagues, friends of EMA Secretariat, friends linked with social media. First of all, I would like to thank presenter Professor Dr. Sharma, Professor Gomez, Engineer Kuma for your nice and elaborative presentation about lightning, its importance, technical aspect, and safety aspect. We would like to we shall continue our talk program with international experts in coming days, relevant issues and technologies. I would like to thank the presenters, participants, friends of NEA Secretariat, friends linked with social media, and I would like to request to participate in coming days talk program either physically or through social media. Finally, I would like to conclude today's talk program and kindly request to IT. Thank you.